Good morning, everyone. I hope you had a relaxing night last night. Sorry we couldn't make the weather any better. That's something we don't have much control over. So. I just have a very brief remarks about what we did yesterday, and then I thought of a couple of things to share with you. Since I looked at the agenda, I found I have 15 minutes, so I said, might as well use them. Yesterday, the agenda was mainly focused on some basics, tools of hybrid simulation, predominantly slow hybrid testing, and several applications that's focused on civil engineering application, if we can call it this way. So we discussed some past and future developments of hybrid simulation. We had a great introduction from MTS to mechanical hybrid testing. And then we had some basics of hybrid simulation, substructuring, integration methods, simulation errors, hybrid simulation techniques. That was an interesting presentation also from MTS. We talked a little bit about Steve Mahan. We will talk about him more during the lunch today. And then we had one very interesting lecture from Andreas about implementation frameworks, mostly Open Fresco, touch upon OpenSeas as well, and also Open Fresco Express, which I'm going to say something about. I talked a little bit about Peer at 21, and then we went through some applications that lined up with the demos we had, small component hybrid simulation and hybrid simulation of bridge bend. We couldn't make a demo on that, but stay tuned. We are going to have tests about this soon. So let me just quickly, before I go further, switch a little bit to show Andreas something that probably he doesn't know, that Open Fresco Express, actually we use that in teaching structured dynamics. So it's a great tool. Last summer, I offered a 2-week course in China, and part of this course had a module in structured dynamics, and Open Fresco Express was actually the tool students have used, and they really loved it. So even though it's something that was predominantly developed to be the light version of Open Fresco, but it had other potential. So let me very briefly show you what this course is about. It's a 2-week course that is called the Hybrid Simulation Design for Smart Cities. So it's also had hybrid systems. It's not exactly a hybrid simulation. And if you go to this link that says tbsi.berkeley.edu, you're going to find this page here. That's a new institute that's joined between Berkeley and Tsinghua. It's located in Shenzhen. And this institute, predominantly funded by Shenzhen government, it has a big part or big focus on data science, and that's where actually the work that I talked about yesterday related to classifying images and the work in SPO, the funding comes from this institute. So the course had several modules, and one of the modules is related to structured dynamics. And in the structured dynamics, so over 2 weeks, we cover a variety of topics, several people involved, and it has a grading system. We had a module about, that's basically a workshop similar to this one, but it's focused on sensors. We have a module that's focused on experimental methods. You see this slide here similar to what I showed earlier, a module about mobile sensing systems, and structured dynamics, which we mainly use Open Fresco Express for it. So anybody teaching structural dynamics may find this very useful. And we show students how to download OpenFresco. It took me some time and with the help of Selim to learn how to do that. And also how to download OpenFresco Express. And then we go through some example very similar to what he showed yesterday. And then we have a module in finite elements, a module in machine learning, a module in signal processing, and finally a module in structural health monitoring. And then what I showed yesterday about the deep learning for images and so on. So let me go back now. I just thought of mentioning that. So, so this part related to hybrid simulation and how it can influence the way we educate students and make them more interested in doing things that combine physical measurements with calculations. And you can take that in a broader context than just solving a structured dynamics problem. Also yesterday, the centerpiece was the effort of Andreas and Selim and so many people who work on the lab. We had the demos. We went over the control room and all the pieces there. We are here in Pier, we're trying to modernize the control room for a while. Development of hybrid simulation after UC-Berkeley kind of slowed down, so we're revamping this again. And then we had the free vibration hybrid simulation and geographically distributed hybrid testing that ended the day. And during the day, we also had a couple of applications that is mainly civil engineering applications, hybrid simulation of environmentally damaged bridges, and then the multi-directional hybrid simulation from Polytechnique Montreal, and talking about some of the challenges that we face with these large-scale testing. So what we're doing today is a continuation of what we have done yesterday, but today mostly focused on real-time testing. How we do hybrid simulation on a shaking table, and also other application. Other here, I mean non-civil engineering, if we can say this is others. So there will be a demo on the shaking table, similar, or the same table we used for this motivational slide that I showed you earlier. Same table, but different application that involve a simple mass that's sitting on some devices and load cells. So hopefully that will go smoothly. When you do something in real time, there are quite a bit of challenges, so hopefully Selim and Andreas are comfortable giving this demo. Yesterday I showed this application here of wind turbine. They're also from MTS. There was a mention of that, and in that we weren't using a shaking table. We were using a system that also needed to be in real time. Because what we were testing is the blade that was modeled computationally, while the stiffener was the physical substructure, and the physical substructure was made of viscoelastic material, so we needed to do things in real time, and results were highly dependent on how accurate we can do that. I showed this slide very quickly yesterday, so I thought of repeating it here. And mainly the people who were interested in this study is if we have the stiffener versus if we don't have the stiffener, how much that will influence the relative deformation at the trailing edge of the blade. So then you see these two red lines here. It shows how much the maximum relative displacement reduced when we had the stiffener. And that's exactly what the study was about, how much these stiffeners will reduce the tendency of this trailing edge of opening up. And this cross-section is interesting because the center of mass is different from the shear center, so you have quite a bit of torsion. The loading on this blade is actually gravity, but because the blade spins, so the gravity becomes like a dynamic load, right? And that's where the hybrid simulation is the loading was applied computationally on this shell structure that was modeled in the computer with that dynamic load, some sines and cosines, because of the spinning of the blade. So that's your loading, and then you compute how much displacement you should put on the stiffener, you measure the force, put it back in the computer model, and keep doing that in time. And you see, the response is pretty complicated, so trying to do that purely analytically is hard. Try to do that purely physically is impossible because of the large size of these blades. The end of the day, we're going to have non-civil engineering application. I just put this thing here. Alex is going to talk about using a hybrid simulation for very different problems that deal with daylighting. So I'll let him talk about that more, where basically we will combine some physical testing. It's not a shaking table, it's not an actuator, it's something else, but also combined with some computational platform. So I will stop here. I'm not going to use my entire 15 minutes, so others can make use of the extra 5 minutes or so. So any questions about what we're doing today? Oh, anything clear? Any comments? Should we do something differently? Should we talk about politics? No, we don't want to do that. Okay, yes.
I have one question. Thank you for showing that I had no idea.
I thought you would like it, so that's why I said, well, I'll show it to you.
Yeah, the students are using it. Was there any suggestions that came out of this?
Let me tell you something. These students, I had nobody of them had any background in structural engineering. These were electrical engineers, mechanical engineers, and interestingly, we got very good feedback. That's probably one of the most popular modules. Why? Because they downloaded the software, they managed to run something that they didn't know before. They didn't know what, I had to explain to them what's a degree of freedom. Of course, they knew what's an actuator and all that. But to be able to solve a structural dynamics problem was new to them. And their feedback is, it was very easy to use the software. It was very informative. They loved the graphics. There were some glitches in the graphics. I think I had a couple of comments about that. But overall, the feedback was very positive. They liked the simplicity of it. And we also made the lectures that give the background of the material consistent with the different steps that you showed yesterday, which basically forming the structure here, options were very few, applying the load, what is the difference between free vibration and having ground motion. So they liked that sequence, and that was positive. The only thing I had to do was some graphic displays that they had some comments about that, but I thought that's minor. We're going to repeat this every summer. It's going to be a recurring event, and within 2 weeks, we teach 8 hours per day, and the students take that. So it's for 10 days, over 2 weeks, and the students have a project. 2 students decided to do their project using OpenFresco. They work in a team, and they did a parametric study where they varied a bunch of things. If you give it to a structural engineer, that would be a trivial. But for them, it was something big because they don't know much about structure damping and things like that. So, or what's a ground motion? So they looked at a variety of input motion and things like that. So to them, it was a learning experience.
Thank you, Professor.
Sure.
One other note we'd like to share. You have a piece of paper on the desk in front of you.